Well, what's a calorie, you ask? Well, calorie is a unit that we can use to measure heat energy. And what I'm going to explain is how we came up with the unit of a calorie. Well, let's say you have 1 gram of water. That's about the size of those blue cubes we use in class all the time. And remember, a gram of water is the same as if we got a graduated cylinder out and we measured some water in that graduated cylinder, that would be 1 milliliter, which is hardly any water at all. That's the same amount as a gram of water. Okay? So let's say you get that gram of water, we take the temperature of it. So let's take the temperature of it. We'll put a thermometer in here. There's your thermometer. Let's see, how about 23 degrees Celsius? Alright, so let's add a little heat to that water. Here's a little fire. And the temperature, of course, would go up. So let's make the temperature go up to, let's redraw the water over here. So we heated it, and now let's put our thermometer in here. And let's say the temperature rose to 24 degrees. Well, how much energy is that? Turns out to take a gram of water, 1 gram of water, 1 gram, and take it from 23 to 24 degrees. In other words, it changed temperature, delta T, or change in temperature, of 1 degree Celsius. It takes exactly 1 calorie. A little typo here. This actually should have been a little c, little C-A-L-O-R-I-E. So that's 1 calorie. Okay? So in other words, you take a gram of water. Here's my gram. You raise it by 1 single degree, takes a calorie. So here's my question to you. What if we took 2 grams of water? So we doubled the amount of water. Let's see if I can do this on this slide. Okay, decided to switch slides. So let's start over with a clean slate here. Let's say you have a gram of water again and it's at 25 degrees. And you raised it up to 26 degrees. That's a difference of 1 degree Celsius. You have a single gram of water. That's what a calorie is. Well, just to clarify a few things. What if you doubled the amount of water? Oops, don't want to do it that way. Let's get the blue. Double the... Okay, it's working out well here. You double the amount of water. So instead of 1 gram, you have 2 grams of water. How much would it take to make your 2 grams go up to 26? And might as well draw a second. Try that again. Looks like I'm a novice here. There we go. There's our 2 grams. So you take your 2 grams, it goes from 25 up to 26. You've doubled the amount of water, and you only went up a single degree. So because you have twice as much water to heat, it would take 2 calories to heat it. Alright, well, let's see how you're doing here. Let's switch it up one more time. Let's say now you have, we'll go back to 1 gram of water. I'll just draw it twice already. And this time you go from, let's start at 20 degrees this time. Let's go up 2 degrees to 22. So you have 1 gram of water, but you want it to go up 2 degrees. So your delta T is equal to 2. Yes, again, you're right. It would take 2 calories. We're back to our original amount of water here, 1 gram, and we're going to raise it 2 degrees Celsius, so it would take 2 calories. By now you might have figured out the formula for calories, and that is a calorie is equal to the mass of the water measured in grams multiplied by the change in water temperature. So if I had, for example, 2 grams of water and I raised it from 25 to 28, that would be a 3-degree difference. That would take 2 times 3, or 6 calories of energy or heat energy to raise that much water by 3 degrees. So that's what a calorie is. This is not exactly what you see on the food package. On the food package, it will actually say capital CAL. That's because what they're telling you is a kilocalorie. So a kilocalorie, or a capital CAL, is 1,000 little calories. So if you calculated in my class 6 calories in a lab and you want to know how many calories or food calories that is, you would have to divide by 1,000. Okay, what I drew here is a calorimeter, which is just a box that you can burn an item in and try to trap the heat in the box so you can transfer it to some water. So basically in our class we would probably have tin boxes, which aren't great calorimeters because so much heat would get out the tin. In the food industry they'd have very well insulated calorimeters. So let's take a piece of food here, or whatever, it doesn't even have to be food, and let's take a test tube. Let's fill it with some water. It doesn't really matter how much water, but I'm going to pick an easy amount to multiply by. So let's get 10 milliliters or 10 grams of water, and I'll call it grams because that's what the formula uses, but 10 milliliters and 10 grams is the same. And what we would do is we would burn the food and try to transfer as much heat as possible to the water. Okay? And so from that we can figure out how many calories were burnt in the food. So let's put a thermometer in the water here, and let's say it started out at 20 degrees, but it went up to, after all the food was done burning, let's say it went up to, how about 40 degrees Celsius. Okay, so that would be a delta T of 20 degrees Celsius. So really, you already have enough information to figure out how many calories were transferred to the water. So what we would do is we'd say, okay, calories is equal to the change, or the mass of the water times delta T. What was the mass of the water? 10 grams. So it's 10 grams multiplied by the change in temperature, 20 degrees Celsius, is equal to 20 times 10 is equal to 200 grams times degrees Celsius, which is a little calorie. Okay. Now, how many calories is that compared to how much food burned? Well, the problem is we didn't really figure that out. We didn't say how much of the food burned. So we need to actually know the mass of the food that we started with. So let's say, keep the number simple here. Let's say if you went and took the mass of that food at the start, let's say it was 1 gram, 1.0 grams. And let's say after you burned it, there'd still be some stuff left when you burn it, right? Like charcoal and stuff like that. So you didn't completely burn all the food. So let's say you took the mass afterwards and it was only 1/2 gram. Well, how much change in mass caused 200 calories is what we want to know. And so it looks like the change in mass is 1/2 gram, right? 1 minus 1/2 is equal to 1/2 gram. So 1/2 gram of food burned caused the water temperature to increase. From that, we figured out it burnt 200 calories. Okay, so really what we have is 200 calories for every 1/2 gram of food burned. And if you take 200 divided by 1/2, we would find that it's 400 calories per 1 gram of food, which is a much better way to report it. We want to know how many calories per gram as opposed to per 1/2 gram. And then if we wanted to convert that to kilocalories, like food calories on a package, you divide by 1,000. So this would be equal to 0.4 kilocalories, or capital calories. Well, I hope that helps explain what a calorie is and sort of how you could use a calorimeter to calculate calories.